Okay, the Algebra 2 review. Getting ready for that test. So here we go. Number 1, solve the linear equation. Well, we look at the denominators and we want to get rid of them to make our life easier. We could multiply by 3 and that would take care of the 1/3, but that would give us 15 halves. We could use 2, which would cancel the 5 halves, but we'd end up with 2/3. So what we do is we want to take each of these and multiply by the common multiple, common denominator of 6. Now remember, we talked about this. There's 2 ways to think about this. You can multiply then divide. 6 times 1 divided by 3 is 2x. Some people like to say 3 goes into 6 2 times, and 2 times 1 is 2x. You get the same answer. It's whatever you are comfortable with doing. Plus, again, 6 times 5 is 30, divided by 2 is 15, or 2 goes into 6 3 times 5 is 15. And then we just have 48. Now, we want to get x by itself. We get rid of the 15 first. Again, think about it. X, think of PEMDAS. First, x is being multiplied by 2, then increased by 15. We have to work backwards to solve for that. So it's like if I give you a present, I put it in a box and then wrap it in wrapping paper. I have to unwrap it before I take it out of the box. Or you do, because I'm giving the gift to you. So now I'm going to subtract and get 3, 2x. I divide by 2, and I get x equals 33 halves. If you want to change this to 16.5, or if you want to change it to 16.5, they are all appropriate answers. Unless the question says, do not leave improper, I am fine with 33 halves. Number 2, best thing here to do is to distribute first. Little reminder, I end up with 3x plus 2x minus 10 plus 1 equals negative 4x plus 11. Now, sometimes I'll see this error where somebody goes, oh, I need to get rid of the 10, and then you add 10, something like that. If you ever have done that, or you have a habit of doing that, then you should go with the idea of putting a line down the equal sign. So whenever you do something, you always do it to one side, then the other. But before you even do any moving, you should always join like terms. So 3x plus 2x is 5x. Negative 10 plus 1 is negative 9. Equal to negative 4x plus 11. Now at this point, I'm going to move. It doesn't matter. I can move my numbers right or left and my letters right, left, or right. I personally am going to move the 4x's over this time because I'm thinking ahead and thinking, well, that'll give me a nice positive 9x. If I would have subtracted, I'd end up with negative 9x on this side. It's okay. It makes no difference. It'll still work out to be the same answer. Since I moved the letters left, I'm moving the numbers right. And I get 9x equals 20. I divide by 9, and I get x equals 20 over 9. Again, I could say 9 goes into 20 2 times, with 2 left over, and 9. And I'm going to leave it like that because it's a repeating decimal. Okay, express the number line in interval notation. So it's starting at negative 5.5, sort of. It's a parentheses because remember, open dot means parentheses. And it's going out towards negative infinity. Remember, think about the number line. Positive infinity is out this way, negative infinity is out this way. Over here, we have a bracket. Bracket means solid dot. And which way is it going? It's going towards positive infinity. Okay, solve the inequality. Well, we want our x's on one side, numbers on the other. I'm thinking ahead. I know I got that special rule with inequalities, so I have a choice of moving the 3x's over and getting negative 4x, or adding x and keeping it positive. I'm going to choose to do that. would still work out. Minus 11, minus 11. Now, I subtracted. Does not mean I flip the symbol. I get negative 2 here. Does not mean I flip the symbol. I divide. Oops. I divide, and I get less than or equal to negative 2 over 4 or negative 1/2. I still have not flipped the symbol. In fact, the whole reason I'm not flipping the symbol is because at the beginning, I moved my x's over to the left and kept it positive. So that is the answer. That's the solution. Now I'm going to graph it. Negative 1/2. It's a solid dot because it's less than or equal. And since it's less than, you get that. Now remember, if I would have moved the x's to the right, I would have gotten this. I would have flipped the symbol and had this. But remember, that does not mean because this is pointing right that I shade right. That is negative 1/2 is greater than or equal to x. Remember, when you're doing this, always read from the x. This is still x is less than or equal to negative 1/2. And then writing that in interval notation, it's negative 1/2, bracket, out towards negative infinity. Negative 5, I'm going to distribute this. No, I don't flip the symbol. But I just multiply by a negative 5. I should go by multiply by a negative number, not both sides of the equation. All I'm doing is distributing. Negative 10x plus 4 minus 15 less than 85. I don't know why my hand wrote 84. Okay, so now I'm going to combine like terms. 4 minus 15. Oh, look what I did. I caught myself. I drew the lines, but I did not distribute. Negative 10x minus 20 minus 15 less than 85. So me probably already caught that, and that's fine. I combine like terms and get negative 10x minus 35 less than 85. I'm going to add 35 to both sides and get negative 10x is less than 120. Guess what? Now it's time to flip the symbol because I'm dividing both sides by a negative number. That's a 12, not a 10. Sorry. Graph it. Negative 12. It's greater than, not greater than equal, going towards positive infinity. So it's negative 12 going towards positive infinity, and it's parentheses because negative 12 is not included. Okay, the instructions on the previous page are the title, compound inequalities. Express the number line in interval notation. Well, we have a negative 12 going out towards negative infinity. It's an open dot, so it's parentheses. We have a 14 with a closed dot, bracket, going out to positive infinity. 2, 5. I mark 2, I mark 5. It's going in between, and I look and see parentheses, so that's an open dot, bam. Solve the following compound inequalities. Well, we have basically, with the OR, we have just two separate going on. The first one I'm going to send the negative in. Again, I don't flip because I'm only doing it to one side. Negative 5 plus x greater than 3. I'm going to add 5 to both sides. Cancel. X is greater than 8. Over here, now I have some thinking to do. A lot of people like to solve to the left, and that's fine. I can subtract 4x, but it's going to give me a negative, which I have to flip around. So I am going to do this, which has its own bag of worms. That cancels, leaving me 5, greater than 4 minus 3 is 1x plus 7. I'm going to minus 7 from both sides, and I get negative 2 greater than x. Now I mentioned that bag of worms, and that's because with this, you've got to remember that it reads this way. X is less than negative 2. So it's greater than 8, open dot, that way. It's less than negative 2, open dot going that way. Now if I was going to write that in interval notation, I'll squeeze that in here. Interval notation, it'd be negative infinity to negative 2, 8 to positive infinity, and we use a union symbol in between. Now 10, the only difference with this is that there's 3 things going on. 3 columns. So when I do something, I have to do it in all 3 spaces. First off, I'm just going to distribute. So negative 24 less than 2x plus 16 less than 22. All I did was distribute the 2. Now, I'm going to subtract 16, not from both sides, but from all 3 places. That's going to give me negative 40 less than 2x less than 6. Now I'm going to divide everything by 2 to get x by itself. That leaves me with negative 20 less than x less than 3. So if you read from the x is less than 3, but x is greater than negative 20. That means we have open dots, and it goes in between. And in interval notation, it runs between negative 20 and 3, open dots being parentheses. Moving on. How many solutions should you get to an absolute value equation? You should get 2. Now, remember this is equal, so we just do 3x plus 4 equals 11, and 3x plus 4 equals negative 11. Remember, I can go right to my split because the absolute value is by itself. I'm going to minus 4 from both sides. I don't have a lot of room, so I'm not going to show it. I'm going to minus 4 and get 3x equals 7. 11 minus 4 is 7. Divide by 3, x is 7/3. I'm going to minus 4 from both sides and get 3x equals negative 15. When I divide by 3, I get negative 5. Now remember, you should check for extraneous answers. So if I plug 7/3 in, the 3's cancel, and I end up with 7. Plus 4 is 11. Absolute value is 11. It works. 3 times negative 5 is negative 15. Plus 4 is negative 11. The absolute value of that is 11. It works. Now, number 12. A lot of stuff going on. I've got to get rid of this 18 first. When I do that, I'm left with 4 absolute value, x plus 9 equals negative 12. I divide by 4. Now my absolute value is alone. And all is good in the world. Except for the fact I cannot have an absolute value equal a negative number. An absolute value is a positive number. So therefore, this is no solution. Moving on. 13. Got to get rid of the 4.5 first. Absolute value of x minus 2.5 over 2 equals 2.5. Now, I get rid of this 2. I'm left with, and here, don't do this. Some people are still doing this. You cannot go x minus 2.5 equals and start setting that up. You cannot do that until it's by itself. So you still take the step to write the absolute value of 2.5 is equal to 5. I should make that big 2 so I don't square it. Okay? Now is the only time where you can bust it up into its 2 separate equations. X minus 2.5 equals 5, and x minus 2.5 equals negative 5. I add 2.5 to both sides. You get 7.5. I add 2.5 to both sides here, and I end up with negative 2.5. Okay? Well, if I plug that in, I get negative 2.5 minus 2.5 is negative 5. The absolute value of 5 is 5. Divide that by 2 is 2.5, plus 4.5 is 7. 7.5 minus 2.5 is 5. Absolute value is 5. Divide by 2, plus 4.5. It checks out. We're good to go. No extraneous answers yet. Okay, absolute value inequalities. Remember, still the same thing. You can't do anything until you get this by itself. And you can't write it in the two separate equations until you get it by itself. So we still start off by saying the absolute value of 2x plus 4 is less than 10. Now, and only now, can you split it up. Okay? 2x plus 4 is less than 10. Now we're going to do the same thing we did with the equations. We're going to write 2x plus 4. We're going to make it a negative 10. The only difference is we have to flip that symbol. Now, we're just solving inequality. I'm going to subtract 4 and get 2x is less than or equal to, no, just less than, sorry. Just less than, minus 4, 6. Divide by 2, x is less than 3. Remember, when I see a less than symbol here, that tells me I'm going to end up with a graph that looks like that. Over here, I'm going to minus 4 and get 2x is greater than negative 14. Divide by 2 and I get x is greater than negative 7. So as I said, it's going from negative 7 to 3 with parentheses, negative 7, 3, open dots. Over here, as soon as I see this greater than symbol, I know I should get a greater than equal. I'm going to get something that looks like this. But I can't do anything until I get rid of the 9. Keep the absolute value, 1/3 x minus 6 greater than or equal to 14 minus 9 is 5. I cannot multiply by 1/3 up here. Multiply by 3 up here. I cannot add 6 up here. I cannot do that until this point when I bust it out of the absolute value. So I write 1/3 x minus 6 is greater than or equal to 5. And I write the same thing, 1/3 x minus 6, but now it's less than or equal to negative 5. Really don't have a lot of room, so I'm going to add 6 to both sides. 1/3 x is greater than or equal to 11. I'm going to multiply by 3 to get rid of the 1/3 and get x is greater than or equal to 33. Over here, I'm going to add 6 to both sides and get 1/3 x is less than or equal to 1. Multiply by 3, x is less than or equal to 3. So both my answers are positive, 3 and 33. It's greater than or equal to 33 that way, less than or equal to 3 that way. Now if I wrote this in interval notation, it goes, oh, sorry, I don't have room for it here. I'll write it underneath. It goes from 3 towards negative infinity with a bracket, union 33 with a bracket out towards positive infinity. 16. Solve for another variable. So it says solve for b. That's right here. Well, a lot of stuff attached. The ax squared is attached by addition, and so is the c. So I'm going to do it all in one fell swoop. I'm going to minus ax squared and minus c, both sides. What I end up with is y minus ax squared minus c equals b times x. Now I'm solving for b, so what I need to get rid of? The x. That's my answer. b is equal to y minus ax squared minus c all over x. Solve for the variable y. This is just what we do with graphing lines. We need to solve for y equals mx plus b. To do that, we minus 2x from both sides. 3y is equal to negative 2x. Get in the habit of putting the x first. Plus 12. Divide by 3. Cancel. Y is equal to negative 2/3 x plus 4. And just as a point, some people brought it up. Remember, when you're dealing with this, there's really no difference between negative 2x over 3 and negative 2/3 times x. It's the same problem. It's just written slightly different. 18. Mike and Jenny need to fix their furnace. They call this Martin Jetco Heating. They quote that it's going to cost $250 for the parts and $60 an hour for the labor. Write an equation for the cost. Well, cost is going to be C. It's going to cost them a flat $250 for the parts. Then it's going to cost $60 for each hour. That's the formula. So, if it takes 4.5 hours, all you do is plug that in. 4.5, that's how many hours are going to be there. And it ends up being a total cost of $520. Adds up really quickly. If it costs $1,150 to fix the furnace, how long do they work? Well, now we're just working backwards. We know the cost is $1,150. We know it costs $250 for parts plus $60 per hour. Well, guess what? We're just solving for H. We're working backwards. We subtract $250. That's the parts. What we have left over is $900. 60H. That means it was $900 for the labor. So it's $900 for the labor, it's $60 per hour. We just divide by 60. And that tells us that it was a total of 15 hours of labor. Okay, number 19. Find the slope of a line going through these 2 points. Remember, it's y minus y, x minus x. Yum-yums on the picnic table. And remember, you can go either direction. Just what I suggest is underline the one you're doing first. To remind you to go -4. And if you need to do this and label x and y, there's no shame in that. Keeps you straight. One of the most common mistakes here is to do x minus x over y minus y. So don't make that mistake. So -6 over, I'm going back to my first one, 5 minus 9. That's -10 over -4, which is a positive 5 over 2. But remember, if I wanted to, I could start with this one and do 6 minus -4 over 9 minus 5. Well, remember, we end up adding here, and that gives us 10 over 4, which again reduces to 5 over 2. Number 20, what's the slope of this line? Well, remember, y equals mx plus b. M is your slope. B is your y-intercept. So, what's in front of the x? Be careful, it's not 4. It's -4. You can also think of it as -4 over 1. Or 4 over -1. And that's important when you're counting to go down 4, right 1, or up 4, left 1. What is parallel to that? -4. What's perpendicular? Well, we have to go from negative to positive, opposite, and then flip it from 4 over 1 to 1 over 4. 21. Graph each one in slope-intercept form. 6 is our b. Remember that right there is b, the y-intercept. My slope is -1/4. Remember, a negative slope when I write my name, it should be going downhill. So if you accidentally go 1, 1, 2, 3, 4, and start to draw a line like that, and you think about your name, wait a minute, that's going uphill. I made a mistake. And that happens. So just make sure you check that you're doing a negative slope. So negative 1/4 means either down 1 and right 4, or up 1 and left 4. And I'm going to do both. 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. And that's my line. Use a straight edge so you don't get sloppy like that. Now, name a solution. A lot of people are confused because, well, there's no shaded area. Exactly. You don't shade for a line. Remember, no shade. It's an equation. Okay? So therefore, the solution is just any point on that line. I say make your life easy. You already know that the y-intercept is 0, 6. Why not use that? But you could use any of these points where you put a dot, such as 4, 5, or 8, 4, or negative 4, 7. Those would all work. Y equals x minus 4. What's my y-intercept? Negative 4. I already know a solution. That point's on the line, no matter where the line goes. I also know it's a positive 1 slope, which means my name should go uphill. If I could spell my name. So it's a simple slope of up 1, right 1. Or down 1, left 1. It's a perfect 45-degree cut through each box. That's my line. That's my solution. Okay, graph in using standard form. This is the cover-up method. I plug in a 0 for x. It makes it go away. I'm left with negative 3y equals 9, so y is negative 3. So I go down. Remember, y is up and down. Then, I cover up. I put a 0 in for y, which makes this disappear. X is simply 9. And then all I do is connect the dots. And then I use either one of those points. I could use 9, 0, or I could use 0, negative 3. Okay, cover-up method. Plug in a 0 for x. 0 divided by 2 is 0. Y is 5. It's right there. Cover-up method. X over 2 equals 5. Multiply by 2. X is 10. Connect the dots with a straight edge. Solution, I could use that point 10, 0. Or I could use the point 0, 5. (25) Graph the equation. You will need to modify each or its special line. So in this one, this is in that point slope form. You got to think about it that this should be x minus negative 4 to tell you what the point is. The point, x, negative 4, y, 5, and the slope is negative 2. If you don't like that method, you can always distribute the negative 2 and get y minus 5 equal to negative 2x minus 8. Add 5 to both sides, and you get y equals negative 2x minus 3. And your CO will still work out. So negative 4, 5. Negative 4, positive 5 is right here. Slope of negative 2, which means down 2, right 1, or up 2, left 1. So I'm going to go down 2, right 1. Down 2, right 1, and so forth. Notice, here, what was my y-intercept? Negative 3 if I did it the other way. What point did I just mark? -3. It works out. Name a solution. Any one of those points I just did. 0, -3, y-intercept. Or 2, -2, 1. Anything along that line. Any of those dots I just put on there when I was counting the slope, that works. If I use slope-intercept, use the intercept. X equals 6. X is always 6. 6, 1. 6, -3,428. 6, 0. 6 never, the X never changes. Therefore, it's a vertical line through 6. So any one of those points I just did would work. Okay, inequalities. Less than or greater than has a dotted line. And see these, how they have that line underneath it? They have a solid line. This is when we shade. We only shade for inequalities. You can pick any point as a test point. The best one is 0, 0, unless the line goes through 0, 0, or it's really close and you can't tell. So, 27. I'm going to use the cover-up method here. You could solve for y also. I might show that also. So I cover that up and I get 3y -12. I divide by 3 and I get y is -4. And then if I cover up that, I divide by 4 and x is -3. It's a solid line like so. Now, as I said, if you're more comfortable with y-intercept, slope-intercept form, subtract the 4x. So you get 3y is less than or equal to -4x minus 12. Divide by 3, and you get y is less than or equal to -4 x minus 4. Notice the same y-intercept. Notice a -4 slope. Up 4, left 3. Down 4, right 3. It still works out. Okay, so at this point, I gotta pick my point. I'm gonna pick 0, 0. It's the easiest one. 0 makes this disappear. 0 makes that disappear. I end up with this statement. Is 0 less than -12? No, 0 is not less than any negative number. So I shade here. And then I can pick any point in that area, like -10, -8. 28. Y is greater than or equal to -7. That is going to be a horizontal line because all of our y's stay the same. What's my error here? My error is it's not solid. This is why it's best to use pencil so we don't make that mistake. So I can go back, if I screwed up, with a pencil and make my line dotted. I really don't have to test because common sense says greater is above. But if I tested a point like, oh, let's say 0, 0, 0 is greater than -7, you betcha, and I can use that point as my solution. I can use any point above that line as a solution. Okay, name a solution. After I graph this, I'm going to divide by -3 because it's really close. I could also do the cover-up method. Either way, I end up with y, don't forget to flip the symbol, -4 x plus negative divided by negative is 6. So my y-intercept is 6. My slope is 1, 2, 3, 4 down, 1, 2, 3 right. Remember, I want my name going downhill. Again, oops, I messed up. Make it dotted. If you remember I said in class, a good suggestion is when you get your test, go through and look at all these and go, oh, that's dotted, that's solid. Remind yourself so you don't make that mistake. I'm going to pick a point. I'm going to pick 0, 0. 0 is less than, 0 makes the -4 disappear, 6. That is a true statement, so I'm going to shade here. And since I tested 0, 0, and it worked out, Just use that point. But any one would work. And here I have -7, that's my b. -7. My slope is 2/3, up 1. 1, 2, right 3. 1, 2, 3. And I can keep going. 1, 2, 1, 2, 3. It is a solid line. I'm going to pick 0, 0 again. 0 is greater than any negative number. So this is true. And again, the test point works, so use it. But anything up there would work.